This exercise is a bit theoretical. I don't think you would get something like this on an exam. Anyway, let's go through it. The first part, to define the concept of similarity of matrices. And in part B, we're using the similarity concept, and we're given that A and B are similar matrices, and we have to prove that they have the same determinant, the same trace, and the same characteristic polynomial. Okay, as for the definition, A and B are similar matrices. I should say that they're both square matrices of the same size. If there exists an invertible matrix P such that this holds, P inverse times A times P is B. There's an equivalent version. We can also use this. AP is equal to PB. Each of these is derivable from the other. Whichever is more convenient, that's the one we use. Okay, and now on to B, subpart 1. We're given that A and B are similar, and I'll use this definition. So AP is equal to PB, and our goal is to show that they have the same determinant. Now, these are equal, so I can put determinant around each. And there's a property of determinants that the determinant of a product is the product of the determinants. So left-hand side is the determinant of A times determinant of P, and the right-hand side is determinant of P times determinant of B. Now, P is invertible, and an invertible matrix has a non-zero determinant, so we could actually cancel this from both sides. These are numbers, and that gives us the desired result, that determinant of A equals determinant of B. Okay, now on to the second part of B, and I'm going to use the other definition of similar matrices. There was this, but there was the equivalent one, this. And remember, our goal is to show that they have the same trace.